Okay, so we'll have a recording of this. Hopefully that'll come out all right. So we've got two eddy current testers. The first one I've got out is obviously a bit older unit. Both of them are made by a company called ECT. This one is the MIZ 22 eddy current tester, and then we'll look at the MIZ 21B in a few minutes. But this one I've already opened the front. So there's a couple latches on top. Pop it open, this thing swings down, and then you can slide it off. You can take the hinges off and get it out of the way. The back is a giant battery. You don't need to open the back for anything. Everything you're doing is on the front. Once you're in here, normally the power cord is going to be in here. Hold it out already. And then your other cables. So you press these two little button things, and we've got the connection cables in here. The only one you're going to use with this tester is the heavier duty one, and it's called a triaxial cable. Okay. To work this, once it's open, this thing plugs in over here. Okay. To turn it on, we have to press and hold for a second the on-off button. And you'll see the screen comes to life. And then it does have a backlight. You can turn that by short pressing the button. You can see I can turn that backlight on and off. So we're going to leave that on. Other things you've got, when we're doing this, we're going to have different parameters we can adjust. And try to get some of the glare off of it here. So parameters that are available to adjust here, we've got our, so at the top, it can actually run two different probes, F1 or 1 and 2. We're only going to use a single frequency. Sorry, it can run two different frequencies. It can alternate between frequencies. You're always going to do single frequencies. So you can see 1 is frequency 1. We're going to leave that. You're going to leave 2 off. Right below that, you can see it says XY. That means we're operating this in the XY plane. That's that inductive reactance impedance plane that I talked about during lecture. You want that to be an XY plane. If you change that to sweep, it's going to change the display, and it'll look a little bit different. You can try using that and kind of see what it's for, but for the most part, you'll be using XY plane. You can see position 1, position 2 there on the next line. That's our starting position, our home position. We'll set that once we start to get the tester set up. We can adjust the frequency, and right now that's set to 100 kilohertz. Hard to see, there we go, 100 kilohertz. We've got our phase. Phase sets the angle that primarily our liftoff, or that all our indications occurs in. So right now that's set to 300 degrees, but the actual setting there is you're going to set that based on how your display comes out. Below that is our gain. The gain is the sensitivity of the detector. So remember, we've got a frequency generator or a signal generator that's going to send AC. In this case, right now it's set to 100,000 hertz AC to the probe, or to the coil in the probe. And that AC is going to create a magnetic field. And then that magnetic field, when you put it near a part, is going to go into the part, and it's going to induce the little eddy currents in the part. And then those eddy currents are going to have their own magnetic field that then pushes back against either the absolute coil or one of the reflection or differential coils. And then that signal gets fed back to an amplifier, which then drives the display. The gain is how powerful our amplifier is, or the way you can think of it is how closely are we listening for a signal. So the higher you turn that up, the more signals you're going to get, but it also means you're going to get more noise. Okay, and so any little wobble of the probe is going to be magnified when the gain is turned up. Okay. This one only has adjustable gain. When we get to the newer unit, the 21B, that also has the ability to adjust the driver power, so how much power you're sending out to the coil. But this one does not. The 22 only, it's a fixed driver power. You can adjust frequency. Okay, and then you adjust the gain. Below that, V and H. So vertical and horizontal, that's the scale of our display. So if we want to zoom in, what do you think we do? Do we turn that up or down? We want to zoom in. If an indication is really small and we want to make it bigger, what do you think we do? You turn it down. You make the scale, you focus in on a smaller portion of the scale. Okay, so right now, The vertical scale is 0 to 1. You know, the horizontal scale is 0 to 11, right? If you make the horizontal scale 0 to 5, you're going to look at a smaller portion of the scale stretched over the same size screen. The next one down is a filter. You can try playing with that if you want. The filter is designed to get rid of some of that extraneous, some of those extraneous indications that are caused by wobble or that kind of thing. But just know, if you don't use it properly, it can also block a relevant signal. So it's designed to block non-relevant or false signals. But if it's turned up too high, or if it's tuned certain ways, it's going to block your relevant signal. We can set an alarm. The reason we do an alarm is if certain indications are going to cause that pointer on the screen to move to certain locations on the screen. We can set like a box or an area on the screen that if our pointer enters it, it'll trigger an alarm. So the way you can do that is you have your tester in one side, you've got a probe in your hand. Often it's hard to be, you know, imagine you're trying to circle a bunch of rivets and be able to watch your screen at the same time, right? So what you can do is set that alarm so as you're, you know, if you're doing like a rivet line on airplanes, you go around each rivet, you don't have to be constantly trying to look at your screen, look at the rivet. You can go around each rivet, and if one of them has a crack and it pops into that relevant area, then your box or your tester is going to beep at you. And then you can kind of do a careful kind of back and forth with it to see what exactly triggered it. So it allows you to do that without having to look. As we go down, the next line there's kind of a space, and then we've got probe, and right now it says differential. On this tester, depending on where we hook our probe up, you can see we've got, on this side here, we've got 3 different probe connections. So we've got one for differential probes. This middle one is single, which is also known as an absolute probe. None of our probes are absolute. They really don't make too many absolute probes anymore. It really doesn't cost that much more to make a reflection or a differential probe, and they work better. So you won't actually use the single probe at all, the absolute. And then the last one here is a reflection probe. So depending on what type of a probe you're using, you're going to have to plug in your cable to the correct connector. But not only do you have to do that, you also have to tell the machine which connector to be looking at. So right now you can see probe is set to diff. That means it's going to be looking at this differential probe port right here. When you're using a reflection probe, oops, too far, we need to set that to differential. Or if you were using the single or absolute, you would do that. The next one down, screen A, you can actually have a screen A, screen B, where you can kind of do a split screen. We aren't going to use that for ours, but and then the last one, it says print HP. You can hook a old school printer up to this thing. We don't have a printer hooked up to it, so you're really not going to use it. The way we go through these different menus is by using these function keys over here. So if you can see I can scroll up or down. The top one there, I didn't mention that, 5 default. You can actually store different settings. So if I'm in there and I scroll to 5, 4, you can see there's like a sweep mode, and you see when I go to these ones, it changes the settings there. Be careful using these. You're going to go through and do setup. You can be in any one of them and then change the setup however you want. Just be careful using them, because there's no guarantees that students haven't used them and changed settings and then saved it. Okay, so even though one of them says reflection right there, okay, even though it says reflection and it is set for a reflection probe, right there, it doesn't mean the rest of the settings are correct. Okay, so I don't really want anyone using any of the save settings, whether it's on this unit or the newer unit. Both of them have the ability to save settings. Okay. So what we then need to do is start hooking up our probes. So, anyways, you can scroll through. You can see as I go down, 2 is off. See if I go to 1, and you can use up, down, left, right. You can see that changes it between sweep and X and Y, or scan. You want X, Y. There's these different types of probes. MX is material sorting. We're not doing material sorting. So you just want to keep that as F1, XY, okay? And you want to keep number 2 there off. We're not doing a dual frequency setup. Okay, so leave that one off. Our position we'll use once we get it set up. A position works like, everyone remember, I'm dating myself here. Anyone know the snake game? Yeah. The little snake that goes around, or like an Etch-a-Sketch, up, down, left, right. That's basically what it is. So once we have our probe, I'll show you on the screen, we can move where that home position is using those arrows, the up, down, left, right arrow. You can see the probe thing here anymore, so I'll make it bigger. And then we'll get into some of these others. You can see right now when I was changing stuff around, it went to 500 megahertz, looks like, or 500 hertz. I can't tell. It's hard to see from my angle. I'm going to go back here and move this just to one of the default ones. There we go, just to kind of clear it out. Okay, there we go.
So the first one is this thing, right?
None of those memories at the top, none of the settings are guaranteed to be right. I have no idea what students have programmed in there and saved. So I would recommend doing a straight setup from the beginning. Now the way you're going to figure out how to set these up is in your lab, it's going to reference essentially the manuals for these. And in each manual, there is a setup procedure for doing surface cracks, which you're going to do 3 different surface cracks. You're going to do flat surface cracks, you're going to do in a radius, and you're going to do a crack and a bolt hole. The setup for those is all basically the same. So you set up for the surface crack, and then you have to tweak it a little bit for each of the other ones. And then the other one you're going to do is a corrosion, is looking at corrosion. And there's a setup procedure for doing a corrosion inspection. Okay? So I'm going to get some stuff pulled out to show you kind of how that's going to go. Okay. So our setup, once we have our machine plugged in, ready to go, we need to hook this up. Now remember, I'm using a 104802, so I go to my chart. 104802 is a hybrid, but we want to run it under differential mode. So I'm going to hook my my cable up to differential, which you can see right now. Hook up to differential, kind of push this in and then screw it down. I'm going to line up my probe here. There is a keyway on this. You can see the keyway there. Inside of here, there's a key. You can see the key down in there, right? So make sure you line up the keyway. This one, all you do is push it in. There's no like lock or collar or anything. Okay. Now I need to start setting up my machine. Okay. This probe, you're going to have a range. It can run at 50 to 500 megahertz. I'm just going to put in some numbers that I'm familiar with. So can everyone see the screen okay? Okay. So I'm going to leave it XY plane. Frequency, I'm going to go, you can start around 100, okay? If I do up and down, you can see it goes in 10,000 hertz increments right now. If I do left and right, you can see it multiplies or divides by 10. Okay, so if you want to go quicker, you can do left, right. If you want to dial it in, say I want to do 120,000 hertz or 120 kilohertz, I can do that. Phase, I'm not going to worry about just yet. Gain, you can kind of play with, well, I'll start at 20. Up and down goes in 0.5 increments. If you do left and right, it goes in 3 increments. Okay. Vertical, horizontal.
So the phase keep the same, 300?
The phase you'll adjust later.
Okay.
Phase we adjust when we get what's called our liftoff. By vertical and horizontal, you can see the screen blanks out a little bit there, but I'm just setting it 6 and 7, see where we're at. I'm going to leave my filter off. I'm going to leave my alarm off. Now I got to make sure I set my probe for differential, which it is. Again, if I move it, you can see I can do single, which is an absolute probe. I can do reflection, or I can do differential. Screen A, I'm not going to print anything. There we go. Okay. You can see when the black line is gone, the arrows don't do anything. Okay. So now I have to get what's called my my liftoff. I need to balance my probe. So I'm going to set my probe on my part. Set my probe on my part, and I'm going to hit the balance button. And now you can see my home position is right there. Okay, if I clear it, you'll see a little dot. You see that little tiny dot right there? I can wobble. If I wobble a bit, you'll see where it comes from. Okay? So that's my home position. And when I'm lifting it up and down right now, I'm getting what's called a liftoff. Typically, you want your liftoff to go basically straight left to right. So this is where that phase comes in. So if I adjust that a little bit, I can go down to phase. And I want to go counterclockwise, right? It needs to go down to the left. So counterclockwise is I turn the phase down a little bit. So if I clear my screen, and what I can do is bring my phase down a little bit. And if I keep doing liftoffs while I'm doing it, I can actually see where it's at. So I think it's pretty good. Like either spot there was close enough to horizontal that you would have been fine. Okay, it's within a few, even 10 degrees of horizontal, you're okay. You see I'm getting a bunch of wobble. Once I've done that, I'm to balance again. Okay. Now I got to kind of see what my indications look like. So if I start running over, make sure my block there is clear. If I start running across, there's my smallest, and there's my medium, and there's my biggest. Now the problem right now, what's the problem with my big indication there? What did it do? Went off the screen. I want to make sure it's on the screen. So it mainly went off the screen horizontally. So I need to zoom out on horizontal a little bit. So if I take my function down to vertical and horizontal, and I'm going to continue, I'm going to bring my horizontal measurement up a bit. So pushing the right one, you can see this where it started was probably where I ended up from last class. Put it on there. I need to balance it again. If I run my probe over to, it's still going off the screen, right? And my liftoff is okay. Let me balance it. So there's my first. Here's my second, my third. Now they're still going off the screen. I might have my gain a little bit high too, okay? So I'm going to go turn my gain down. You can't just keep increasing the screen because what will happen is you'll do what's called oversaturate the probe. This is a fairly small probe, and so if my gain's set too high, it'll actually be, it's like a speaker that you're sending too much power through, where it starts to clip and all that. So if I can't adjust it, I can do it. On the newer unit, it'll actually tell you if it's doing that. You rebalance. Okay. 1, 2, 3. Okay. Now my vertical, I probably need to zoom in a little bit on it, right? Because they're all squished together. We want to spread those out vertically. So go down to vertical. Up and down arrows are vertical. So I'm going to bring that down to, let's try 3, see where we end up. Let me rebalance my probe. 1, 2, 3. You can see it's kind of a game you play. Let's go. We turn horizontal up a fair amount. My gain's probably set too high still. I'm doing my cheat sheet here. Oh, yeah. Let's see what I can do here. Rebalance. There we go. Okay. So you can see you're going to kind of play around with vertical, horizontal settings, gain, and all that until you get where it's filling the screen, not going off the edge. Okay. And so, and then you'll have that. Again, this process, oh, I know why my numbers aren't matching up. I'm using a different number than on my cheat sheet here. This process, you can vary it with frequency. You may have to adjust your frequency a little bit. You may have to adjust your gain a little bit. And so, again, follow this. There's a setup procedure. You follow that to kind of learn how to do it, how to do different adjustments until you can dial it in so everything's on the screen. So one other thing I want to show. So remember, this is our liftoff indication, right? It shoots straight off the side of the screen. And then I showed you what the crack indications look like. The last one is you have to demonstrate an edge effect. So if I take this to the edge, you can see it creates what looks like a crack, but then it never returns back down to the origin. Okay, here's my lift off. So that's an edge effect. There's our lift off. Boom, boom, boom. There's the 3 crack indications. Okay, so you need, those are the things you need to show. I wouldn't necessarily show them on the same screen. What a lot of people do in their reports is they show a lift off and edge effect, and then they go back and clear it, and then they show like there are 3 or 4 cracks, okay? And do that. So you'll play around with dialing this in and doing that.